An 8 kilogram object lies on a rough horizontal surface. It is attached to a light, inextensible string which passes over a smooth pulley. The other end of the string is attached to a freely hanging object of mass 10 kilograms. When released from rest, the acceleration of the system is 5 meters per second squared. Find the coefficient of friction. So, this mass here is 8 kilograms, and therefore its weight is 8g. And the reaction force then would be R. There'll be a tension in the string pulling this way, and clearly the object will slide to the right, and therefore the frictional force will be to the left. And if it's moving, then we know that F will be the limiting friction, and therefore equal to mu R, where mu is the coefficient of friction. Over here, we've got a 10 kilogram object, so we've got 10g and t. So let's look at this object first. So we know the system will accelerate in this direction, and up here then it's going to go to the right, and we're told that that acceleration is 5 meters per second squared. So if we use F equals ma for, again, this object here, the resultant force is 10g minus t, and that is going to be equal to the mass times the acceleration, therefore 10 times 5, which is 50, and so let's call that equation 1. Now up here, we know that the motion is going to be along the surface, and therefore R is equal to 8g. So, looking horizontally, we have t. Take away F. F is going to be equal to mu times R, which is 8g. And that's going to be equal to mass times acceleration. The mass is 8, acceleration is 5, so that's going to be 40. And so that's 2. Now, we can remove the tension by adding these equations. So I'm going to do 1 plus 2, and then I'm going to get 10g, take away 8 mu g, and that's going to be equal to 50 add 40, which is 90. So 8 mu g is going to be 10g take away 90. Now, if g is equal to 9.8, what's 8 times 9.8? 78.4. So this is 78.4 mu is equal to, if g is 9.8, that's 98 take away 90, so that's 8. So mu is equal to 8 divided by 78.4. So we've got 8 divided by, my last answer is 0.102. Correct to 3 decimal places.